Richard, calling me a liar publicly was the worst mistake of your life. TCMA. TCMA did not cause this accident. It's impossible. Let's first look at the thrust control module and the thrust resolver angle and the excitation. That link has nothing to do with the common core system. Verification would be affected by the common core system, but the actual TCMA logic looks at the TRA from the excited signal direct to the thrust control module. So how this works is you've got the permanent magnet alternator in each engine, generating alternating current to power a rectifier located in the EEC, which creates the DC power required to power the EEC. Then there is an exciter which takes that and creates an alternating current signal, which sends that alternating current signal out to the thrust control module through a series of wound transformers that move around to send a signal back called the TRA, throttle resolver angle. So the resolver is what's being detected by the exciter. This has nothing to do with the common core network. TCMA protection, look, it's going out from the EEC, based on a lack of deceleration of the engines when the TRA is detected at idle. Now let's find that in the Boeing documentation. So this is from page 189. Let's find the TCMA data from the Boeing documentation. Now, page 316 of that same document. Zooming in on a little part of TCMA, and then we'll go into the details of TCMA. Point number 3. The engine computer, EEC, reads each winding of that transformer in the thrust resolver angle sensor that I told you about, and validates the 2. That's 2 per throttle. You've got the left and the right, each have 2. So, if these signals pass electrical checks, but the 2 within the right or the 2 within the left disagree, depending on whether or not you are at power or on the ground, so whether you're at power or on the ground, the following will happen. The EEE select will select the higher value to maintain the maximum thrust setting out of the 2 channels, or select the value closer to idle, the lesser, for thrust control malfunction on the ground. So if it's on the ground, it'll pick the lower. If it's in the air, it'll pick the higher. It doesn't say that it will go to idle. Next, EEC thrust management. You have the TCMA and overspeed protection. A TCMA, or the TCMA, is defined as an uncommanded, uncontrollable overthrust condition, also known as an uncontrollable high thrust, in which the thrust lever command, the actual TRA, resolver angle, cannot decrease thrust. So that's where we're lowering the amount of thrust on the resolver seems to not be creating less thrust. The engine's not responding. That is a thrust control malfunction problem where it's just not coming down. Okay? Next. The EEC limits the engine to the approved rotor speed limits. The usual EEC control of engine fuel flow is via the fuel metering valve in the fuel metering unit. That's on the engine. If an overspeed or overthrust condition occurs, the overspeed protection circuit, or the TCMA, overrides the active-inactive channel function. Okay, you can read that. Importantly, the EEC TCMA function is active when on the ground. Weight on wheels. And monitors to make sure that engine thrust decreases when the thrust levers are moved to engine idle. Next. Page 344. Thrust control malfunction accommodation is the engine control function that prevents a thrust control malfunction event from becoming hazardous to the airplane while on the ground. The TCMA function monitors engine thrust relative to commanded thrust. So the actual thrust relative to the to the thrust resolver angle sensor's commanded thrust. And make sure, that's a typo from Boeing there, amazing. Make sure engine thrust does not adversely affect airplane safety. The TCMA function makes sure the airplane handles acceptably under high asymmetric thrust conditions for on-ground conditions. On-ground conditions. Let's just skip forward to what makes this happen. So here, a TCM event is detected when all the following conditions are true. Airplane's on the ground. No, it was not. Airspeed's less than 200 knots. Yes, it was. Altitude is less than 17,500 feet. And selected N1 is more than the TCMA threshold, which I don't know what that is. But we can say we were not that. We were this, we were this, we were that. So already we don't quite meet the conditions of a TCM event. We don't yet meet the conditions. Even if we did, once the event is detected, the TCMA function would only happen with the following. TCMA function commands engine shutdown by closing, energizing the fuel shutoff valve, the ones on the engine, not the spar valve. The high pressure fuel shutoff valve drivers, which close and mechanically latch the engine fuel valve if TRA, throttle resolver, is in the idle flat reverse region. It was not. The throttles were found by the EAFR to have been in the takeoff range the entire time. So stop this. Please stop it. Stop talking nonsense and stop calling me a liar on your channel. Stop it. You are wrong. And I have never made a false claim. I have all of the technical documentation in front of me. I have everything I need to make a well-informed decision.